All right. Hello, everyone. Welcome to today's Corundum developer meeting. Thank you very much for finding the time to tune in today. All right, so let's go ahead and get rolling here. Mainly, I just have a little bit of status update information for you guys. So let's go ahead and get into it. Let's see. So just a quick summary. We got the FIFO memory inference bug that is in Intel's hands. We'll see if there's any updates on that. Got a couple things to say about simulation. Did some hammering on that week before last. Couple things to report. And then we got the priority flow control, EXI virtual FIFO, and then switch version of Corundum to talk about after that. So let's go ahead and get cracking. So bugs. First, the FIFO memory inference issue where we were having some problems with MLabs in Quartus. Let's see. Joachim, do we have any status updates on this? I know it was handed off to Intel and they were looking at it. Have you heard anything back yet, or are we gonna have to wait for Ulrich to get an update?
No, I'm not aware of any update. He didn't mention any. So
Okay.
I think
All
there
right.
was no activity.
So it's reported Intel, they're taking a look at it, but I guess as of this point, well, I guess maybe they said try it on the latest version of Quartus and see if it's still a problem.
No, maybe I can't
That's
remember.
okay. You're not the
Was
right
there a
person to
new
ask.
version? Did they release a new version?
Did they release a new version? I mean, they release them periodically. I'm not sure what the latest version of Quartus is off the top of my head. Let me see what the latest version I have installed is. The latest one I have installed is 22.3. They may have released one more after that.
Yeah, they've got 22.4 and then 23.1.
Oh, they have two more versions. Yeah, all right. There were I was running some weirdness with Quartus as well. I might need to try downloading the latest ones. They have 23.1 now. All right. Yeah, I guess we should download that and give it a shot and see if we're still seeing the same problem there. Well, I'm not sure who's working on that at Emily. If it's not Joachim, then maybe we'll have to check back on that next time and see if there's any news to report. All right, well, I'll move on to the next thing then. All right, so simulation updates. So Verilator has been something that I've wanted to use with Corundum for quite some time because it's much faster than Icarus Verilog for simulation. So that means all of the big test benches and whatnot will run a lot faster. In January, they released a new version that has a fix for kind of the main bug that was breaking CocoaDB integration. It basically meant CocoaDB didn't work at all. So after that was fixed, I was reasonably optimistic that we'd be able to get Verilator working for most of the test benches in Corundum. So, well, and all supporting components and whatnot as well. So week before last, I went ahead and took a crack at that, see if I could make it work, but discovered a different problem, which is potentially a much bigger issue. This one seems to be more of a design shortcoming in Verilator itself, because basically the VPI support in Verilator is sort of an afterthought at this point. So mainly you can read everything, but writing is not really fully supported. Aside from writing like top level signals and potentially updating like internal memories and things like that. So basically, in Verilator, you can't drive signals that are not top level signals because even though the VPI put value call actually works, the new value is immediately overwritten at the next, timestamp or time step processing operation. And unfortunately, several core Corundum test benches have to drive internal signals due to limitations in the signal abstractions of CocoaDB. So basically, I tend to use a lot of concatenated buses, like all of the Ethernet ports and whatnot. They're all just multiple concatenated AXI stream interfaces. And there isn't any way in CocoaDB to kind of slice and dice that and hand off signals to different driver components. So there's basically three possible ways to fix it. Either it needs to be fixed in Verilator, which I don't know if that's going to happen, or CocoaTB needs to be reworked to support splitting signals and handing those off, which that's, I think a non-trivial thing to do if it's going to be done right. Or the top level HDL test benches have to be rewritten, or they don't have to be rewritten. We would need to use top level HDL test benches instead of just instantiating the module directly, where we can then repack the signals appropriately. So, I mean, that works, but it's kind of a pain to have to write all of those. So yeah, not sure what's going to make the most sense here, but I think for the time being, I'm going to put Verilator on the back burner again until either we have better support in CocoaTB for handling these concatenated signals so we can drive everything from the top level, or that Verilator has better support for actually using VPI put value down in the hierarchy somewhere. So yeah, not so great, but maybe we'll circle back to this a bit later once some stuff has been updated and improved. All right, so moving on to priority flow control. So let's see, I guess, so we have two different students that we're going to be working on a couple of things. One of them is going to be focusing on priority flow control, but I don't see him on at the moment. So I don't have a status update on this in terms of the actual implementation, but my understanding is that some progress is being made on kind of the first component of the sending and receiving of PFC pause frames and implementing some of the counters. So the idea with implementing priority flow control is so that we can support, lossless fabrics. So I don't know if anybody on here is more familiar with what's required for PFC to work correctly, kind of at the NIC level. We're definitely going to be taking a look at, how some existing NICs do that, right? If you're going to use PFC on, say, Mellanox NIC, what needs to be configured? But I'm not sure if anybody on here has any insights. Well, we can pick that up during the discussion later if somebody has something to add in terms of priority flow control. But the hope is to get this operational within, before this summer sometime. Because there's a researcher at, what was it, UCLM, I think, that wants to do some work with PFC in Corundum in terms of looking at congestion control in networks. So yeah, all right, so moving on then. What I've been working on over the past couple of weeks, aside from the simulation stuff, is the AXI virtual FIFO module. The idea here is that we can provide a very deep buffer in DRAM for packet traffic. And if we can support storing basically 100 gig Ethernet at line rate into DRAM and then pulling it back out, that's a pretty good starting point for functionality like this. So we have to basically merge together two memory channels in order to get enough throughput. I have kind of the FIFO channel module working, although I now need to rework that to support segments such that we can actually get the necessary level of efficiency. I have the decode logic working in simulation, borrowing a few bits and pieces from some of the PCI TLP handling code, which is segmented, and I'm working on the encode logic. I have stuff writing into kind of the internal FIFOs and looking at the packet length information. So the next step is to kind of put it together where you tack the header onto the rest of the data and repack segments. So got a few more things to sort out there, and then I probably need to make a few modifications to get the timing performance where it needs to be. But progress is being made here. Now, the last thing is the switch version of Corundum. So there's two different research groups that are interested in doing something with FPGAs, with an FPGA-based packet switch of some sort. One is interested in PFC, the other one in TSN. So there's a question of, what would the architecture for, such a switch look like? And, how do you put that together on an FPGA? So kind of what I'm thinking about in terms of capabilities is like maybe, 10 gig to 100 gig operation with a reasonable port count. And for PFC, we need, multiple traffic classes / virtual channels where you can prioritize one virtual channel over the other ones. And for TSN, you might need something similar in terms of being able to, prioritize certain low latency traffic. So whatever you put together for the switch fabric, it has to be able to support this in a relatively efficient way. And then also, obviously, need some sort of switching capability. I'm thinking for now we can start out with just really basic Ethernet switching, and then later on maybe something a little bit more powerful can be dropped in later on in terms of IP routing or more general match action or whatever. But the most important thing is to keep the resource utilization relatively reasonable, such that you can actually fit a decent number of ports on an FPGA. So there's some question about, what kind of board would be useful for this. Alveo boards are good for maybe, 8 ports at 25 gig. There are other PCIe form factor boards that'll give you more boards or more ports, maybe up to 16 ports at 25 gig, 4 ports at 100 gig, which is, not too bad. But in terms of a switch, that's still pretty small. There's also other kind of dedicated boards like the HTG 9200 that can give you a lot more boards, or possibly hang in some additional QSFPs off of like a VC118 could be a good option. I did get an email from some folks at Arista because they make basically rack mount FPGA based switches. I'm not sure exactly what the capabilities of the their FPGA design are. It seems to be more geared towards like HFT applications, but nice thing is it's a rack mount box. So it might be a little bit easier to work with than a bare board like an HTG 9200. So that could be something to consider as well for a target. But the real question is, are there any kind of useful references or existing designs that we can take a look at? So over the past couple of weeks, I've been poking around on Google just to see what I can find in terms of various research papers relating to switching on FPGAs. And I found a couple of references that seem interesting. It's basically kind of the starting point was 3 papers from Wayne Luke, and a couple of them also had Papa Filippo. And the 3 papers are, the first one's like kind of a feasibility investigation of various switch designs on FPGAs. So they looked at a couple different ones, and kind of the conclusion of that paper is that the grouped crosspoint switch seems to work pretty well on FPGAs. So the grouped crosspoint switch, it's sort of a hierarchical design where you have sort of several smaller sub switches that are put together to form the full, crossbar, and each internal sub switch has some buffering capability. So that means that you don't have all the buffers at the input or at the output. You have some inside the switch fabric that makes the scalability a little bit better. And then they had another paper called I think it's HyperNet. Not 100% sure the pronunciation on that. They actually have HDL code available for this, and this one kind of has this optimized combined scheduling and crossbar in the data path. So highly pipelined. It's sort of like a sorting network type thing that is used to push the packets into the appropriate slots for the output. I guess the downside of this that they talked about in the next paper is a relatively high resource utilization, but it seems to get pretty good throughput. And then they have a third paper on what they call a queue balanced switch. And it's basically an output queued switch with this sort of round robin queue balancing thing on the input, which I guess improves buffer utilization inside of the output queued switch. But from the second 2 papers, I kind of have a couple outstanding questions. Maybe I'm missing something important here. I'm not 100% sure, but there seems to be a significant difference between, packets and flits. When I think of packets, I'm thinking of like an Ethernet packet, which can vary from 64 bytes to, 1500 bytes or 9K bytes or something. It's not something you transfer in a single clock cycle. It's going to be transferred over multiple clock cycles, versus a flit is going to be something much smaller and fixed size that you could transfer in a single clock cycle. but both the HyperNet thing and the Q-balanced switches, they both seem to be accepting full 256-bit packets every clock cycle. So how you map that onto, or how you map Ethernet packets onto those is not something that's immediately clear. Because it seems like if you were to just take the packets and, break them up into, smaller flits that you could send through the switch, well, then you would have to de-interleave and handle flit drops after going through the switch. And that seems like that's going to be just a nightmare in terms of, the amount of buffering that you need and whatnot, because you would need like one buffer per input port per traffic class for every single output port. And that's not scalable. So I don't know, I might be missing something on there. Maybe there's some resources, some references in terms of, how you properly take a packet, break it into flits, and then go back the other way. That's relatively efficient, that would work with one of these switches. Or maybe these designs are just not appropriate for something like Ethernet packets. Not sure. And there's also the question of, how do you implement things like virtual channels efficiently, right? Because if you want, say, 8 virtual channels, does that mean you need 8 times the buffering? Not sure, especially in terms of handling things like flips and pulling things back apart after this type of switch. So not quite sure about that, but the group crosspoint switch from that first paper does look rather interesting. So I've been thinking about, okay, if we're going to take something like that, how would we turn it into an actual Ethernet switch that you can, use for experiments or whatever. So my idea at this point is to build something hierarchical. So the most complex parts of the switch are going to be the crossbar, the scheduling, and the route computation. I mean, okay, what else is there in a switch anyway? But hierarchical switches seem to work well on FPGAs. So if we can, kind of group things together and then pass it off to the next level in kind of an aggregated way, it seems like that's probably going to be a more efficient way of doing things. So like with the GCQ switch design, that makes sense. The other thing I was thinking of is that route computation is going to be more closely linked to the packet rate, not the data rate. So if you were to build, say, route computation logic that could work at 100 gigabits per second, which I think for 100 gig Ethernet is something like 148 million packets per second, something like that. If you, say, replicate that across all the ports, if you're running at 10G or 25G, you would be able to support a much higher packet rate than line rate on those ports. So it would make sense to be able to share that route computation logic. So these kind of things dovetail a little bit because, well, what you could do is, say, aggregate kind of at a first level ports together so you can share the route computation logic across that group. And then you can aggregate them together to have, one higher bandwidth port into the crossbar. So for example, you could aggregate ports in groups of 4 and then present 100 gig ports to the internal crossbar. And then the internal crossbar, only has this, one relatively high bandwidth port type to deal with. So you can actually, potentially even mix and match different port groups. So for example, if you want some 100 gig uplinks on a switch with a bunch of 25 gig ports, if you aggregate the 25 gig ports up to 100 gig internally, then the crossbar only has to deal with 100 gig ports. It makes the design a little bit more straightforward. So that's kind of what I'm thinking about here. I'm not sure if anybody has any ideas to build on top of this at this point, but that's kind of what I'm thinking in terms of a path forward in terms of the switch. So obviously we need the crossbar inside, and then we have the route computation logic that can be shared across multiple ports and built into these kind of port group modules. So that kind of separation that might make things a little bit easier to design for the switch. All right. so that about wraps up what I want to talk about for the status updates. At this point, we can open it up to, general discussion. I don't know if we want to talk about, the switch in more detail. Carlos, you said you took a look at some of the reference information.
Yeah,
I'm
I
not sure
also
if you
read
have any ideas from that.
Yeah, I also read the main article and see how you what you have explained about how to implement it, dividing the thing in the switch fabric, the scheduling logic, and the root computation logic. I don't understand very clearly how can we change from, for example, the dynamic change from 4 ports of 25G to 1 port of 100G without reloading the FPGA. I don't know how we could implement it, because if we have like different, I don't know also which will be the interfaces for the switch for the packets. If they will be, I think, access stream.
Mhm.
So if the data width is different for 100G and 25G, depending on how we process the packet, I don't know. Yeah, for the at least for the computation logic, how we could implement it dynamically so that the resources are also well spent and not wasted.
Right. Well, we can set aside, dynamically reconfiguring, because it's like potentially you could support that, but we'll set that aside for the time being. In this case, by mixing and matching different port groups, you can have, one module that's 4x25, another module that's 1x100, and then you can mix and match. You could drop down, say, 2 of the 1x100 and like 4 of the 4x25, and then have a 6-port kind of crossbar those are connected to, if that makes sense. And then, yeah,
Okay.
obviously you do have to width convert. But I guess there is a question of exactly kind of how that would be passed through. Depends on how much, reordering and latency that you can tolerate. Well, not reordering, how much interleaving that you can tolerate. Yeah, potentially, if you have packets going to different ports, you might be able to interleave those, right? So if you have, say a 25G and your data coming in at 25 gigabits per second, and you want to pass that through to the crossbar at 100 gig, well, maybe you send, one cycle of that packet, every 4 clock cycles, something like that. And then obviously the other end that has to be, put back together. So that would be lower latency than if you have to spool the whole packet and then transfer to 100 gig, because that would also work. But I think that's probably going to be the only way to support running a very large switch. If you want 16 or 32 ports or something like that, that there may have to be a bit of aggregation to make it work. Not sure. We may need to explore this space a little bit.
Yeah, okay. I also have think about for the road computation logic to try to also do it like very parameterizable, so that we can establish like the starting point of the packet in which we start the comparison and the length of that part, so that we can select exactly the part of the header of the Ethernet frame or whatever. Maybe we can choose between the destination MAC address to choose to compare it with or to do the comparison in the CAM, or select another field, just doing it very parameterizable.
Yeah, I'm not sure what makes the most sense there, because we could certainly try to build something that's very parameterizable in the HDL. We could certainly build something that looks more like a match action kind of pipeline, or we could also just kind of start out with something just baked in, just looking at MAC addresses. Because there's definitely a question of if you're building cams, the width of those cams is a pretty critical number. So if you build something that can support full MAC addresses, that's going to limit, if you are using it for something narrower, how many entries you can have in the cam or whatever. So Yeah, not sure the
Yeah.
best approach for that. And also, I guess the other question is, how much can you pipeline, things of that nature. I know Xilinx does have some CAM IP. I don't know much about how it works internally. It's probably a closely guarded secret and patented and whatnot. But there's definitely precedent for running things like CAMs on FPGAs. I'm not sure about the the dimensions of those CAMs though. That's definitely something worth looking into.
Okay.
Hi, Alex.
Hey, how's it going?
Hey, I have some idea. May I share?
Sure.
Yeah. So it's about a switch topic. There is a paper in internet. I can saw it. It called Panic. Have you ever seen it?
Panic. Yeah, that sounds familiar.
Yeah. It's a paper that's write about high performance programmable NIC for multi-tenant networks.
Right.
Yeah. And I think it is a
Usenix, OSDI?
PANIC.
Yeah, OSDI 2020.
Yeah, maybe 100 gigabits. Maybe 25.
Yeah, no, I found the paper, right? It's OSDI 20, Panic, a high performance programmable NIC for multi-tenant networks.
Yes, that's right.
Yeah.
Yeah, and I think it's a good idea. Maybe we can implement to the Corundum in application part.
Right. Let me take a closer look at this paper. So I see a switch fabric in there. I mean, I guess one thing as well is that there's probably a little bit of a scale difference between running some sort of an embedded switch in a NIC versus running a trying to build a much larger packet switch.
Yeah.
So but I guess one thing about this kind of maybe port group abstraction is that if you build kind of a small switch into the port group, that could potentially be used on either of them. Not sure. I'll take a look at this more in detail. I think this is definitely a paper that I've heard of, and I think I looked at it a while ago, but need to refresh my memory on exactly what's going on here.
Okay.
Is this a paper that you're more familiar with, or?
No, I'm just researching about how to accelerate more efficient network card.
Right. Okay.
Yeah, and I think maybe there's another idea is use AU50, that Xilinx product, and it can have 4 max in 100 GPS.
Right. Yeah. No, I mean, the idea is to support, whatever boards, Corundum supports potentially, but 4 ports is not all that many from a switch perspective. So, but I think I think a number of people in the community have the U50s because they're pretty reasonably priced cards. I think Carlos, at least, I think has a U50 or 2. So,
yeah. Sorry, I'm a student, so it's a good way to start it.
Yeah, definitely. No, the U50s are good cards. I mean, I think these days, if I was going to recommend a card for somebody to start out with, I would probably say get the if they're in stock, the C1100 cards. It's the same FPGA as the U50, but you get 2 QSFPs instead of 1.
Yeah, and the Xilinx answered me that it supports 4 max in if I go 10 gigs.
10 gig. It'll also do a 25 gig.
Yeah,
Yeah,
it can
you
also
get 1
support
port at
10
100 gig, or you could do 4 ports at 10 or 25. So
yes, and it have 4 max in 1 port.
Right.
Yeah, so it's interesting. So
yeah, there's definitely a lot that we could do with that. Yeah, we'll take a look at the Panic paper here. Is there something in particular that you had in mind about that paper that was interesting?
yeah, I don't want to bother other people, so maybe you can see it after the meeting.
Okay.
Thanks a lot.
All right. Yeah, well, I'll take a look at that paper and see if there's something useful in there in terms of the switch. But yeah, I guess actually that was one thing that I was thinking of a couple days ago, is in terms of if we wanted to support something like SRIOV in Corundum, we need to be able to sort of have a small amount of packet switching logic effectively to route packets to the correct queue. And you could use, Ethernet switching or IP routing logic to do that. And if you can use double duty for a switch and for, SRIOV support in the NIC, might as well. So this could potentially end up being quite useful once we get stuff working. All right. So is there anything else to talk about in terms of the switch?
Alex, you think starting with RMT makes things too complicated too early?
I was leaning towards just looking at Ethernet switching without trying to do anything, particularly complicated. So the idea is that we'd be able to drop in, some other kind of route computation logic, including some sort of RMT pipeline down the road. But you get the switch working first, just as an Ethernet switch, get all the kinks worked out of it, make sure it scales up to, the FPGAs that we're working on. And, and then later on, once we, get more familiar with working with switches and whatnot, and in terms of, what kind of constraints are available, then maybe we can do something more comprehensive.
Fair enough. There are designs out there, including with HDL.
Yeah,
Don't know
if you
about the
of
maturity.
any,
I
if
can
you know
send
of
you a
any good
few.
references for that, go ahead and drop it in the Zulip, and if I don't look
I'll
at it,
send
then
you.
I'm sure Carlos will take a look.
Yes.
Yeah.
Thank
And
you.
by the way, just the panic paper, I think the first author used to hang out here, if I'm
Right,
not
yeah.
mistaken. Check out her
They-
first
they,
name. I think she was around a couple of times.
Yeah, they pop in and out occasionally. Yeah, I haven't seen Josh in a while, but yeah, they have been on here. So
Yeah.
but yeah, that one's I think definitely worth taking a look at, because I think they were basically putting a switching fabric on the NIC. But I need to take a look at the details on that. All right. So is there anything else to talk about in relation to the switch?
One question.
Yeah, sure.
In the board, the HTG, the 92.
Yeah, the big honkin', the big red
Yeah.
board from High Tech Global, the big expensive board
Uh,
from High Tech Global.
Yeah, I have seen that there are like 3 FPGAs available for that board. Or
Yeah.
3 different implementations. So which are you porting to this board? Which?
Well,
or
the 2 boards that
them,
I
or-
have the 9 Ps, but the 13 Ps are bigger. I think Alberto has one of those, right?
2.
1, 2.
Yeah.
In principle, it doesn't really make too much difference which variant you have, as long as the kind of top level is flexible enough. Obviously, things like placement constraints are going to be different, but the board is the same, so all of the pins are the same.
That
Yeah,
board has
the
a
High Tech Global board, that HTG 9200 is a slightly weird board because it was designed for ultra scale parts. So that kind of limits what sites are pulled out and whatnot. Versus if they were to design it today for ultra scale plus, it would probably look a bit different.
The good thing about that board is they have this one FMC socket, and they have a specific daughter card for it where you can plug in a Zinc. So if you want to at some point they have an SDN control plane attached to your data plane, that platform is pretty interesting.
Yeah, I was also trying to figure out how to get some PCIe connectivity to that.
I can tell you that it's not pretty. A lot of SMA cables.
Right. Yeah. So I think for PCIe, there's kind of 3 potential approaches for that. One of them is to use those SMA connectors, a whole lot of SMA cables, which probably works, but
I think they're limited to by 8. Yeah, so you're gonna have a lot. You need another expansion card
By
from
8.
them.
Well, I guess it depends. The SMA connectors on the board is only a by 4, I think, or you go off of the FMC. And there's potentially a couple different solutions going off of the FMC. Probably the way to keep yourself from going crazy is that I think you can get some boards from Samtech that go to the Firefly optical modules.
We went
then you
over
can do
that a crazy route, and I kind of got to the end. For that board, it doesn't work. You
Off
can
of the
do
FMC
Firefly,
or off of the onboard Firefly?
the Firefly, and
Onboard ones.
I ended up talking to Samtech quite a little bit. They have great solutions, but not off of the not for that particular board.
Right. Well, so I actually came up just a few days ago with a potential solution off of those Firefly connectors, because the optical modules don't work, but they have electrical cables for PCIe now, which sit in those same connectors. So I was thinking the electrical ones are potentially more easy to customize because they can just, you know, you can swizzle the wires however you want.
I can go back to my notes. There's something that doesn't work. I have the solution here, but I knew that it wouldn't work with the HTG 9200. But the PCIe over Firefly from Samtech is super cool. You can double the PCIe bandwidth for other boards. I have to recover why exactly for the HTG 9200 that solution didn't work. I had exchanged.
Right. So the optical modules don't work because they put 10 TX on one and 10 RX on the other. And the Fireflies want 4 TX and 4 RX on each for the PCIe ones. So that's why the PCIe Firefly optical modules don't work. But my thought is that, well, maybe you could, you know, you could take the 2 sites and then cross connect it to 2 sites using the electrical connections. You get a basically customized electrical cable made.
That's where I get into it. Like,
so
you could do it. They are not
work.
going to sell this to you. Yeah.
Well, I don't know. I mean, those cables, they custom make it when you order it, right? Because they're just soldering the cables on both ends. So they might be able to cross connect it without too much difficulty. It's like, that's within the realm of possibility. It's then just a question of whether you could plug the electrical cables into that that Dolphin board and then slot that into a host machine. I sent an email to those guys a while ago, but didn't get a response back. So
if you want to get to the bottom of it, there was a technical support people that they were really helpful, but this was, I don't know, we talked about this a couple of years ago.
Yeah, no,
And,
I remember that discussion, and yeah, the conclusion was that the optical modules just wouldn't work on that board. So anyway, I just discovered those electrical cables recently. I'm like, well, it's worth taking a look at. If it works, that would be useful, because then you'd have the FMC site available and you'd use these otherwise pretty useless Firefly sites for 8 lanes of PCI Express. So anyway, that's definitely worth a few cycles to see if we can get that operational. All right. So does anybody else have any questions or comments about the switch? That's definitely seemed to have generated some interest. It brought Alberto back.
I would have been back eventually anyway, so it was just a bonus. Yeah.
All right, well, if not, we can certainly pick that up on the Zulip channel then, for anyone who's interested. All right, so I think Victor had something he wanted to talk about, so we'll turn it over to Victor then at this point.
Sure. Hi, everyone. So a real brief in here. So Victor Manuel Vilches in here. Roboticist, but also a big hardware nerd, I guess. Been around for quite a few years using hardware acceleration for various topics involving robotics mostly. So in a nutshell, making robots compute faster. I work for Acceleration Robotics. Let me guys give you a link in here, which is a startup that builds semiconductor building blocks for robots. So in a nutshell, we build IP, soft IP mostly, that then essentially gets landed into FPGAs. Also, we build kernels for GPUs that make essentially computations in robotics faster. We focus mostly on the robotics pipeline, so everything between perception, navigation, manipulation, but we also tackle things downstream from the OSI stack perspective. So we look also at the networking stack, we look at the things such as the data link layer, and so on and so forth. I've got a long history working with semiconductor vendors, but I won't bother you with you. I'll tell you about the fact that we also lead an open source community called the ROS2 Hardware Acceleration Working Group, which packs every month a few hundreds of folks that show up in our monthly meetings and essentially learn, contribute, and bring up projects like this fantastic one to the robotics ecosystem. And we work mostly around something called ROS, which is the robot operating system. If you've ever played around with robotics, state-of-the-art robotics, you might have heard about ROS. The name itself is a bit misleading. It's not an operating system. It's a framework for robot application development. Think of it as a toolbox that includes different tools that you need to build things that are useful with robots, such as manipulation tools and navigation tools and perception tools and control tools, and then interfaces with actuators or drivers. So ROS, as the de facto standard for robot application development, is the piece to accelerate when it comes to FPGAs and GPUs. So looking deeper at that, we have recently been involved and funded for a project that essentially is looking at various NICs and UDP IP implementations. We did a bit of research, reviewed the state of the art, tested a few projects, and essentially bumped into Corundum. Got blown up by the amount of people monitoring this and using it and speaking good about it. Reached out to some of our clients and partners, and we got super good feedback from both Intel and AMD. So we said, well, there we go. Plus, I must say, I've been monitoring the community for a bit. So yeah, very impressed about that as well. And we're hoping to bring a bit of value to Corundum. Again, reasonably new to the project, so expect us to be a bit clumsy, at least on these first few beginnings. But our goal itself, the first goal, I would say, hopefully we can bring many more, is to port Verilog Ethernet, which seems to be a key building block of Corundum, to KR260, which is one of the targets we're using for our daily work. Shortly, and in a nutshell, this is custom FPGA SoC board, which carries an ultra-scale Sync UltraScale Plus SoC. It's a pretty nice board because it doesn't only include the typically PS connected Ethernet PHYs, but also it has PL connected Ethernet PHYs plus an SPF plus connector. So pretty interesting for our target, which is benchmarking actually various combinations of a fully fledged networking stack working on programmable logic. So our key intention, our key objective actually is to benchmark from a latency perspective various UDP IP stacks that may run in the PS, PL, and various combinations within the PL. So for that, we're hoping to grab Corundum and bring it up to speed. If you take a look at the last link that I shared in the chat, that brings you to the ticket where we hopefully will be tracking our progress. Please let us know, let me know, particularly if anything we're doing is bad or wrong, we will correct it. But we just thought it made sense to bring this up as a ticket that we will be updating periodically. The discussion will be below for everyone to comment or follow, but we'll just be updating the first comment because that's what typically people read in the tickets, especially those ones that are long. And so we'll be launching questions to the community as things go on. We have picked first the CCU 102 as the closest target based on our source code inspection, but please do guide us if that's incorrect. And our first goal will be to reproduce essentially the example provided by you guys, by Alex, I believe, on how we can get that 10 gig working on the board. So yeah, very excited about this. Our ultimate target, and this is the last link I'll share, will be to hopefully feature part of our work in a project we're conducting with Harvard, actually, and a few other institutions, academy, but also industry, into what we call robot perf benchmarks. If you guys have played around with machine learning, you might have heard about MLPerf or ML Commons these days. Is the industry standard for how to evaluate machine learning performance, especially in hardware accelerators. We're hoping to bring up the same thing in the robotics world, and actually we're working with the same guys. So the main author of the MLPerf paper actually is the guy I'm bringing this project forward, BJ Janapareddy from Harvard. So yeah, that's pretty much it. Hopefully we will be adding value to the community twofold, I guess. First, bringing up a new port for a board, documenting it very thoroughly so that people can build on top. And two, of course, providing reproducible, and that's very important. performance benchmarking from a latency perspective that not just ourselves, but others can also benefit down the road. That's pretty much it. And yeah, please let us know if you have any feedback or experiences that we can build upon. Maybe 2 quick questions I had while reviewing the documentation and content. I did try to do my best on tracking all related topics, but at some point, I guess I might have missed something. I saw in related tickets that, Alex, I think you recommended a series of points for people trying to make ports. One outstanding question that I had was, could you share which transceiver did you use to test out the CCU 102? And maybe related to that also, which networking card, 10 gig networking card did you use?
Let's see. I just used some random DAC cable that I had lying around. I don't know where it came from, but it works fine at 10G. So it should work with whatever. If optical modules, you have to be a little bit wary of some of the control pins. If the TX disable pin is pulled wrong, you're going to spend a long time pulling your hair out before figuring that one out. As for NICs, I think I usually test with like the Intel 10G, like the X510 maybe. But anything should work. Like if you plug a breakout cable into Connect X4, Connect X5 NIC, that also should work. So if you're gonna buy a NIC, I guess it's dependent on kind of what speed you're running at. If you're doing stuff at 10G, it probably makes sense to get a 10G NIC. If you're potentially going to be doing stuff at 100G, then well, maybe you get a Connect X4, Connect X5, and a breakout cable, and then that'll support both. So, but yeah, we've had pretty good luck with the I think that the X510 Intel NICs, and those can be had. I think they're a few years old now, so I think you can get those for a pretty reasonable price on the used market. So.
Okay, thank you. Yeah, maybe I'll ping you afterwards just to make sure we use something that's tested and known to work. We're hoping to also somehow report on this so that others can follow. Well, we're gonna have to buy everything, and we're targeting the 10 gig. So as you said, it should be pretty known technology. So hopefully we can get it.
Are you guys doing anything with PTP?
Yep.
Okay. The X510s work pretty well with PTP. The Mellanox, all the Mellanox NICs that I've tried so far have issues with PTP. And that caused a lot of head scratching because I'm like, I thought this worked. What is going on here? Where did I screw up? Oh, wait, the problem is actually the Mellanox NIC. Under load, you can get screwy timestamps out of the Mellanox ones. I don't know if I'm doing something wrong, but that's what I've noticed. And the Intel NICs, no problem. So yeah, right now I actually don't have any 100 gig NICs that work correctly with PTP under load. Mellanox NICs are fine when it's not under high load. So just FYI there.
Cool. Thank you so much. And yeah, if anyone has feedback, as I said, just drop it in the issue or just let me know.
Right. Oh, one thing I will mention real quick in terms of porting Corundum, you don't really need to build Verilog Ethernet and the PCI Express stuff, separately, build example designs for that first. It's really a requirement if you're porting to like a new FPGA architecture, right? Where you might have a, different transceiver interface or, different PCI Express interface or something like that. So it's like when I'm porting to like a new Intel FPGA, it definitely makes sense to run these components separately, get the kinks worked out, and then get Corundum running. But if we already support Zinc UltraScale Plus and you're porting to a Zinc UltraScale Plus, you don't need to port it necessarily. But if you're going to be using that stack in isolation, then by all means, that's a good thing to do. And also it can potentially be useful just for, getting familiarity with the pieces, just to make sure everything works in isolation if you're, new to working with this stuff. So it's like there's probably going to be boards showing up in Corundum that I don't bother making a, PCI Express or Ethernet reference design for. But for something new, yeah, I'm definitely going to start with those.
Thank you. No, that's useful and makes total sense. Yeah, we're we're gonna just follow your advice, and we also thought that we could learn a lot from just reproducing and bringing it to a new board. Also, we're already bumping into a series of issues here and there, probably something bad on our side. But no, overall, we think this is important, especially also as we aim to kind of like split the pieces and then reassemble them in various combinations, because that's gonna get us some more flexibility. And not every single combination has been demonstrated. At least that's our understanding so far. So maybe it has been, and maybe we just haven't seen it. But yeah, for the sake of clarity and benchmarking purposes, we will hopefully gain better understanding this way.
Yeah. Okay. Yeah, I just took a quick look at the issue that you posted there, trying to figure out what's going on with that log output, and it looks like the out of context runs failed for some reason, but I think those must be writing to different log files, so that specific failure is not in the log that you posted. But you
Yeah,
can try.
that is the prompt that you get out of running the command. I'll take a deeper look at the logs and then see if I can track the exact issue. Yep.
Right. Yeah, the out of context log, it actually, in the log that you posted, it prints out the log files for the out of context logs, like the file names, but it doesn't actually include the log output, right? It just says failed runs and then lists the 2 out of context runs. So something between, when those runs started and when they failed, there was something that took place. So I'll have to take a look at one of those logs to see what happened. But those should just be for the transceivers, I think. So I don't know why those would have failed. That's literally just that's like a Vivado internal thing, right? That's created with a TCL script. And then that should just run. So that's weird.
Maybe that's a fair question to ask, which is what was the last Vivado version you tested the CCU 102 reference design with?
Yeah, so I think right now I'm mainly running with probably 22.2 or 22.1. Let me take a look at exactly what version I have installed. I need to re-up my Vivado license to use the latest version. I think they have a 2023.1 maybe now. I'm not 100% sure. 2022.1 is the latest one that I have installed. I think that's the one I've been using, unless I've been using 2021.2. One moment here. Let's see, which one have I been? I guess I've been using 2020.1 or 2021.2 instead of 2022.1. I need to take a look at the license to see if I can use 2022.1.
Yeah, I can use .2 in the FPGA card.
Which one? 2021.2?
Yeah,
2022.1.
22.2.
22.2?
Yeah.
Has that been released?
Yeah, I can implement in the.
It's been released, but I so based on, and I'm just speaking out of personal experiences while working with AMD, but the most stable one is the one Alex mentioned, the 2022.1. At least known to us. That's the one we're building up on, because it's currently the one that gives the least issues so far, especially when interfacing with other packages and libraries from AMD.
Okay, so yeah, I guess they have 22.1 and 22.2. All right, well, I need to take a look at what tool version I've been using. I think I've been using primarily 21.2, but yeah, 22.1, do you think is a good version to target? All right, yeah, that probably makes sense.
Nevertheless, I'll just note it down that you've been working with 21.2 and 2021.2, and I'll give that a try. Though installing Vivado again is a total nightmare, but yeah.
Right. Well, I mean, the thing that doesn't make sense is that, so the way the run that failed, it's created using a just a TCL script, and that TCL script looks like it ran correctly to create the IP core. No errors there. It's just then when Vivado ran the out of context run to build that, the out of context run failed, and it's like, and that part doesn't make sense. Like, I think depending on what you're building, if it needs like a separate license, that can fail, right? So like if you're building for one of the 100 gig designs with the CMAC core and you don't have the CMAC license, then that'll fail because it doesn't have the license. But this is for the Frappin GTH transceiver. It should
Exactly.
work. There's nothing that needs a license there. So that's a bit of a head scratcher. But if you look at the at the log for the out of context run, it should tell you what the problem is. In some cases, it's just you got to do a make clean and then make again. It doesn't work.
How much memory do you have on the box building?
Hang on, I didn't. The audio is being weird at the moment. What did you say?
I was just asking how much memory is on the build box server.
Oh, the
Oh.
build box.
I've had the out of context stuff crash because it ran out of swap or ran out of memory.
Okay. So Victor, how much memory do you
I've got
have?
like 64 gigs plus a huge swap.
Pretty good.
That should be fine. Okay.
Yeah, it should be fine. Yeah,
Good thought.
plus. Yeah, it's a really good one. Thank you, Tracy. Actually, because I actually it's a great guess. I've been bumping and fighting with AMD quite a few rounds about this. So yeah. No, that hopefully that's taking into account. I think it should be fine.
If you need any assistance on how to crash things or not build it, I'm an expert. Call me.
All right, we'll keep that in mind. All right, well, keep us informed how that's looking.
Will do.
You
And
run
thank
into any
you.
other roadblocks, Yeah. For the most part, porting to new boards is usually pretty straightforward. It's just with the Zinc devices, when you bring the ARM cores into the picture, things can get a little bit screwy. So I had some issues getting stuff running on one of the ZCU boards. I think it was a ZCU 102. It took a while to root out what was going on, but there was a combination of some weird TCL thing, and then also you have to set some flag because they have, I guess, 2 different memory modules installed depending on what board you have. So there's something in the FSBL that checks to see what memory module is installed and then changes the memory module config or something. And you got to poke something over TCL so that works properly. It's like, anyway. But that should have nothing to do with this particular problem because this is entirely on the Vivado side, on the FPGA side. And I might need to look into getting one of those Korea SOMs. I don't know when they released the one with the SFP port on it, 10 gig port.
About last year.
That was last year. Okay, so that's pretty new. Yeah, because I know they've had the other version of the Korea out for a while, and that wasn't all that interesting because it didn't have anything wired up to the to the PL. So, this one's interesting. So you said it looks like it has 4 1 gig ports plus the 10 gig port. Are they all
correct.
wired to the PL, or do some of those go to the PS?
No, so the 4 that have PHY, 2 of them go to the PS, 2 to the PL. They're all
Okay, got it.
1 gigabit, and then there's the SPF plus connector. And yeah, you're totally right. The what was originally released 2 years ago was the K26 SOM, which is the SOM itself, and then the carrier board KV260, which was meant for vision-oriented applications. But yeah, what they did essentially is come up with a different carrier and then reuse the SOM, and that's where things started getting really interesting, as you just said. So I'll drop you an email, or just I'll write you in the chat, Solip, which I'm still getting familiar with. And I'm sure I can help out getting you aboard, Alex.
Oh, all right. Well, that works. That works. Yeah, I think it'll be pretty straightforward to get it running on there. Yeah, it's like usually when people are asking about porting to Zinc devices, I'm like, well, Usually they're not even wired to the PL, so you can't you can't use it. I've definitely had people asking about using the Verilog Ethernet code on various Zinc boards. I'm like, well, on your board you don't have a usable PHY. But on this one, I guess there are actually 3, right? 2 at 1 gig and 1 at 10 gig that would be usable from the PL. So yeah, that would be a useful one to have. Actually, one thing I will say is that it might make sense to look at like the VCU 108, VCU 118 builds, because those they use both the 10 gig port and the 1 gig port. So it's like if you look at the VCU 118 10 gig design, depending on how you configure the dip switches, it'll insert the 1 gig port into either the TX side or the RX side of the 10 gig path. So you can stick a loopback module in the 10 gig port, and then basically test that with just a 1 gig link. So I'm not saying you should do the same thing for that, but that is something I put together on those boards for testing stuff. If you don't have the 10 gig NIC, well, hey, you can just pop a loopback in there, plug in the 1 gig connection, and check to see that the 10 gig design works. So
That's pretty useful. Thank you.
all right, so do we have any other questions or comments from anybody else? I don't know if Emily has anything. Oh, okay.
Yeah, just a quick one if we have time
sure.
still, but we can also defer that to a chat or something. So the question would be rather generic, and to be honest, I didn't look at the documentation yet. The size of a received packet in the RX descriptor, or to be precise, in the completion, can that be larger than what was actually received? Is this a valid case? I'm looking at some code and just confused about this. Is this signaling that the NIC had to?
On that. I need to double check on that. At some point, the length is clipped to what was specified in the original descriptor, but I can't remember if the completion reports, the original length before it gets clipped, or if it reports the clipped length. I need to look into that. That's a good question. It's possible you can get a bigger value if the packet was truncated.
Yeah, the driver code suggests that this is the case because it checks whether the completion size is less than or take the minimum of both the actually allocated size and the reported completion size. And I wondered, why is this even necessary? But could make sense if this is the way for the NIC to report. I had to clip something. Okay.
Yeah, I think I'll need to double check the code, but I think that's the case. It's like if you say set up a receive descriptor for like, I don't know, 4096 bytes, right? 1 page, but you get a 9K jumbo frame in there, it will only write 4096 bytes, right? It will only write the requested size. That's kind of important. But I think it will report the original packet size in the completion. So yeah, maybe what I should do is add a flag somewhere saying it was truncated.
yeah
that might
a message sense. At least such a write output once message, something like
that. Yeah well, right, so the descriptor in the completion format is something that I'm kind of planning on doing a little bit of reworking at some point, for at least the descriptors to support the variable length descriptors. That's going to be reworked a bit. For the completions, I might do some rearranging and whatnot there as well. And potentially adding a flags field is going to be a good idea. And we can certainly have a bit packet was truncated, and then you can look at that and go, oh, okay, that's an error. Yeah. Yeah, I'll double check on that and let you know for sure. But yeah, I think it does report the original original length.
And the second question would be, the driver currently, as far as I see it, does not use multiple descriptors in one block.
For RX?
It uses just one. For TX, it's a different story because the kernel can go ahead and have multiple fragments, but for RX at the moment it's just one. And I'm just wondering, was the design ever checked actually with having multiple parts also for the RX side?
The test bench tests it that way, I think.
Ah, okay.
So
good.
the hardware should support it. I think I just never bothered implementing it in the driver because you can get the higher
Yeah.
order pages. So I'm just like, well, I'm just going to do that.
Yeah,
But
we're
yeah.
currently working on rearranging the memory allocation to avoid an initial copy within the kernel networking stack. And
does that not
as
like
far as
higher order pages, I guess?
Yeah, I'm currently not sure if that's possible. We try to do the following, and this is also done by other NICs or drivers. They build the SKB in a way that the so-called, or I call it that way, I don't know if that's the correct name, the linear part, the linear area of a packet which is directly attached to the SKB with a data pointer. And these NICs try to put the RX buffer into this data pointer more or less, so that the hardware is directly writing into this linear area, which will make the kernel, the kernel then does not have to pull especially the headers to do processing from the first fragment.
So I think there's a trade-off though. If you're using like XDP, that's I think going to be more based on just having the complete packet in pages directly. And if you pull the header into an SKB, that might cause trouble there. I'm not 100% sure about that, but that was
the
my
point is,
understanding from looking at how some of the NIC drivers work, is that they do everything in pages and then they just attach the pages to an SKB and kick it off to the stack.
But the problem there is then that at least there's one copy action going on.
Copying the headers,
when the kernel needs to look at the headers, it tries to just pull, is the word here, to pull the corresponding amount of headers into the so-called linear area first. And we try to optimize that to get rid of that initial copy. Profiling shows that there is something to this. It makes sense.
Yeah, no, I was just thinking, I wonder how hard it would be to set things up such that you can switch between one allocation method and the other, depending on whether you're actually using XDP, right? So it's like when you attach an XDP program, then you will refill the RX queues using just pages. When you don't have an XDP program attached, then you use SKBs and you fill the linear portion with some portion of the packet. Not sure.
I'm not there yet, but I've also looked at the XDP side, or at least the RX side of XDP. It doesn't seem so complicated to have this combination, since basically what they are doing and what we are trying to do now is kind of registering the first fragment, or what's the first fragment now currently, registering this as the linear area, basically.
Actually, I just thought of what it might be. It might have something to do with XDP sockets, and exchanging, exposing memory to both user space and to the NIC. And under that setup, you might not be able to use the linear portion of the SKB.
Yeah.
That might be what it is.
Mm-hmm.
But in principle, if with that kind of a setup, it seems like, you would have to fill up the NIC RX ring pointing to data that sits in the application memory, right? So I'm not sure, if you allocate that, user region for storing the packets and associate it with the socket that's associated with the NIC, I'm not sure exactly what takes place at the driver level in terms of setting the NIC up to write stuff into that memory region.
Good question. That's something I did not look at yet.
Yeah,
This
it's like I think
XCP
there's
socket
some
thing.
justification for why a bunch of NICs are doing it without using the linear region, because from my mind it would make sense to write out the header separately. You should be able to do that. And in fact, I need to double check the how things are set up in Corundum. I think that's how all the test benches are set up. But yeah.
So the reason for asking initially, to go back to the question, is I'm under, or at least that's a fact, in this linear area, the kernel needs the SKB shared info at the end. That's always the end of the linear area. So essentially what happens is, if at least if we look at pages individually, we now have two descriptors, or need to have a block of descriptors of the amount of 2. Since the first part needs to be filled up until the page is full minus SKB shared info, and then a second part. And that's what I'm not sure about, if we can take the result of the alloc pages function, multiple pages, and just use that as a linear area completely over multiple pages. I'm not sure about that.
I'm not sure about that, but I mean, what might make sense there is to allocate SKBs from the kernel and then just use that. Right, the kernel has calls for allocating SKBs. In fact, Corundum originally was written to work that way. It would allocate an SKB from the kernel, and then it would write the packet into the SKB, and then it would return it. At some point,
you mean in the data area, which the kernel is allocating using the right function, it allocates a linear area which can be then passed on to hardware, you mean?
Well, okay, so there's several different ways you can allocate memory, right? You can allocate memory, you can allocate pages, but you can also just say, hey, give me a blank SKB.
Which usually carries a page fragment for the data pointer.
Okay, I mean, I don't know what the kernel is doing in the background. I guess that's possible. Instead,
at least that's what I saw.
The ones you get from the kernel, it's not linear.
No, the function which is currently in use, the NAPI get frags, that function is actually allocating the SKB, allocating a page fragment, and attaching it to the SKB itself as the data pointer and the shared info.
Right. Well, so with the current setup, the SKB is allocated after the receive takes place, right?
Yeah.
But you can allocate an SKB beforehand.
Yeah.
Right. It's a completely different set of calls to do that. You don't use NAPI get frags. It's something else. I can't remember what it is right now. If you go back in the Git history, it might be there. I can't remember when I changed it.
Yeah, I mean, NAPI get frags is just a wrapper around allocating an SKB and then a data pointer, a linear area.
Right.
So
yeah, but
we are currently not yet working with jumbo frames. So for now, one page would be okay for us. More than okay, actually, even minus shared info and minus any padding needed for doing encapsulation and so on. but I have nevertheless the question, okay, if we want to want to support jumbo frames with that kind of allocation scheme, then it might be necessary to basically have two descriptors for one frame, which means using a descriptor block in Corundum terms.
Right. Yeah, I mean, eventually I'm going to support variable length descriptors, so you can attach as many, fragments as you want.
Yeah.
And I guess the advantage of something like that is then you might actually get, more efficient utilization of pages, because let's say
Yeah.
you're using jumbo frames. Well, one, you need 3 pages, I think, for a jumbo frame. Right now it's effectively allocating 4, which is wasteful. But then if you receive a small frame, well, if you can just hand off
Yeah.
one page instead of 2 or 3, then that's also an advantage. So that's another thing that you can do. Now, if you have like one SKB with the linear region plus plus an additional page or 2 for overage, well, then you can just hand off the SKB if you didn't use those pages, and then allocate another SKB and just swap that out. So there's some reorganizing and stuff that needs to be done to support that, I think, in the driver, but potentially it could be better from a performance perspective. Now, the flip side, the other thing I'm not sure about is, like the number of pages that you have mapped and, associated with the hardware. I'm not sure if it makes more sense to use like larger pages and register fewer of them versus using, like using order 2 pages and registering a smaller number versus using, normal pages and registering a larger number. I don't know if that has an impact on performance.
Good question. Yeah.
Because going through all the steps of, registering all of those things and mapping them and adjusting the IOMMU and yada. I could definitely see registering a lot more pages as being a performance problem, but I don't know.
Yeah, we are also already in this area thinking about reducing our number of RX queues. For now, we have a symmetry, the same number RX queues and TX queues.
Well, so one thing that wouldn't be hard to do, or wouldn't be particularly difficult, I just haven't had the time to sit down and figure out all the details. ETH-Tool can set the size of rings and also the number of rings. There are APIs for that. They're not currently implemented, but I don't think it would be that hard to implement. So something like that is potentially worth looking into, because then you can benchmark and run with different numbers of queues and see what makes sense.
Yeah. We are actually, while we're at it, well, we are actually also thinking about when we are reducing the number of RX queues, then reduce it to the number of CPUs, CPU cores or threads or whatever. At least that's our current thinking, to, on the one hand, reduce the number of needed pages which get allocated beforehand, or at least on upping the interface, and then also all the mapping stuff. And also to be able to have longer queues than if, I mean, currently we have those 4,000 RX queues with, we have just usually 64 gigabit of memory available. So given the number of cards with the number of ports, it's really using a lot of memory currently. And we kind of came to the conclusion that we don't really need that many RX queues anymore.
Well, how many RX queues? Oh, you said did you have it like 4,000 RX and
4,000?
TX?
Yeah, it's in symmetry
with
the TX side. On the TX side,
we generally run with a large number of TX queues, but then like 256 RX queues or something,
Yeah. And we are actually also thinking about reducing it dynamically to the number of available CPU cores.
Right. Well, that's what I'm saying. If you take a look at implementing some of those ETH-Tool APIs, then you can experiment with some of that stuff. But yeah, it probably would make a lot more sense to come up with some more sane default values, right? If you need 4096 queues, well, then you can turn them on. But if you don't need that many, maybe limit it to 1,000 queues or something by default, unless you go poke it with ETH tool.
Yeah, or the other extreme. What about I have no argument against that. What about reducing the number of RX queues to just the number of CPU cores? I mean, in the end, there are just so many CPU cores, and
well, so I guess
what's the argument for more
the thing
queues
with
than
the number
CPUs?
of queues is it kind of depends on what you're doing with them. So under normal operation, if you're just using RSS with your RX queues, you probably just need one per CPU core. But as soon as you start using things like XDP sockets, well, every socket needs a queue. So at that point, then you start needing a very large number of queues. So
okay, that's the argument then. Okay,
that's the argument for supporting very large, or that's one argument for supporting a lot of queues. But that doesn't necessarily mean you need to have all those queues active at all times, right?
Yeah.
So
yeah.
Well, I guess another thing that you can do that's pretty easy is just adjust the RSS configuration to use fewer queues and just see what that does to performance. That's just one register to poke at.
Yeah. That's also the next step. We the problem is that we have modified the RSS to take advantages of all those queues. So yeah, within our scenario, I have to come up with the scenario where actually only just a few queues or the number of CPU cores or whatever is actually used. But I think we are going to move away from that and go in the minimum direction of just having the number of CPU cores for the number of RX queues. As long as those XDP sockets, good argument, thank you, is not needed.
Right, like I said, it really depends on what you're doing. If you don't need those queues, then turn them off might make sense from a performance perspective. If you need them, then you need them. So if you guys aren't using XDP, then if you want to turn it down to just 4 queues or something, then hey, great. If that gives you better performance, that's a good idea. And the other thing maybe is the event queues. Right now I just turn on event queues for every available interrupt channel, but maybe it makes sense to consolidate that down to 1 per CPU.
Yeah, we actually put together a patch. It's not really tested so far, but which offers more or less, for starters, a module option to say, okay, I want to have that specific number. I want to have the maximum. I want to have adjusted to CPU count for the event queue and for also allocating the IR queues.
Okay, that sounds good.
I guess in the end we'll have a pull request for this when it's done, ready, tested.
Right, yeah.
Not much code show.
Yeah, I guess another thing that I'm not sure about is anything NUMA related, which is probably not something you guys are worried too much about. But like if you have 2 CPU sockets, I don't know how the memory allocation and whatnot works with respect to that, and pinning IRQs and things like that. I think historically that has been a problem to make sure that the IRQs get spread across multiple CPU cores. And then also
it's still a problem.
When you're running across with a NUMA setup where you have 2 CPUs, you want to make sure that for NIC anyway, that all of the IRQs are running on the same CPU that the NIC is actually connected to, and that you're using memory off of that CPU. There's
I would
probably
expect
improvements that can be made to the driver with respect to that, but this is getting well outside of my wheelhouse. So
I'm not sure. I mean, I would expect that the IRQ balance daemon is taking care of that. But currently, it's for us, it's a little bit acting up because it's not optimally distributing all those IRQs, even on our simple systems with just 1 CPU. So there are obviously cases every now and then. I would say even in 30% of the cases where obviously 2 processes, 2 IRQs are processed on the same CPU with high load each. So I'm wondering, why is the IQ balance daemon not moving them onto different CPUs automatically? It just sits there idle and does nothing. A little bit strange. I'm expected that this problem is a problem of the past, but obviously not.
Apparently not. Well, what can you do? Actually, the funny thing is, I don't think I've ever really played around with IRQ balance. I've just run with whatever the defaults are, and it seems to work reasonably well. It's like as long as every IRQ is going to a different core, it seems like things should load balance reasonably well, assuming RSS is doing its job. But
Yeah,
I don't know.
Yeah, I mean, it also depends on the power of the machine. I mean, our machines are not that powerful. So if you have a top-notch CPU, then, well, might not be a problem, or might not be visible or that visible.
Right, that's true. That's true. Yeah. Definitely should do some more testing on lower end machines just to see what can be improved. But yeah, whatever you guys come up with, we can certainly entertain it.
Yeah, we'll now see what that rearrangement of memory allocation brings, if it works at all, how I imagine it or saw it in other drivers. And hopefully we will get rid of this initial copy so we are in the SKB context here, exclusively, no XDP yet. And
Right.
yeah,
All
we'll
right.
see.
Well, and if you guys want to look into implementing some of those ETH tool APIs for screwing around with the numbers of queues and whatnot, that'd be great, because that'll make it a lot easier to play around with some of the stuff at runtime. Like you can use the kernel module parameters to set like the defaults, right? And then you can go change it with ETH tool.
Yeah, we'll keep that in mind. Perhaps we'll need it, then we'll implement it.
That's usually how it works, right?
Yeah.
When you need it, okay, then it gets implemented. If you don't need it, well, okay, we'll get around to that eventually. All right. Let's see. So
Okay.
definitely a bit over the scheduled hour, but that's fine. That means we've had a lot of good stuff to discuss. All right. Does anyone have any other questions or comments or anything you want to discuss? If not, then we can adjourn for a couple of weeks. Let's see. When is the next one going to be? Today's the 13th. 2 weeks will be the 27th. All right. Going once. Going twice. All right. Well, see all you guys in 2 weeks. Thanks for tuning in.
Thank you.
Thanks.
Thank
Bye.
you. Bye.
All right. See you guys.
See you.